Okay, in this question we're going to look at directional derivatives, and this is an example. Find the directional derivative of the function f of xyz equals xy squared plus y times z cubed, so just over here, at the point 2 minus 1, 1, in the direction of the vector I plus 2j plus 2k. Okay, so first off, what we got to do here is find the gradient, grad of f essentially. So what we're going to do is get the partial derivatives of f, and let's go there. So just recall f of x, y, z is equal to xy squared plus y z cubed. Okay. Partial derivative of f with respect to x, that's simply y squared. Simple enough one there. Partial derivative of f with respect to y is, well, let's look at this part here. It's 2 times y squared, so that is 2 times 2xy plus yz cubed up here, so that's simply yz cubed, that's simply z cubed. Finally, differential of f with respect to z. There's no z term in the first part, only in the second part. Simple enough one here again, 3yz squared. So the gradient of f, grad of f, is, by definition, it's the derivative of f with respect to x, that's the I component, plus the derivative of f with respect to y, that's the j component, plus the derivative of f with respect to z, and that is the k component. Okay, so what we have here is grad of f is y squared I plus 2xy plus z cubed j plus 3yz squared k. Grand. Now what we're going to do is evaluate that at the point, let's just go back up here and recall that we have to evaluate this at the point 2 minus 1 and 1. So at point 2 minus 1 and 1, what do we have there? Well, y squared is minus 1 squared, so that's just 1. 1 I. We'll just leave that alone for a second. 2 times xy, so 2xy is 2, let's just write it in here, 2 times minus 1 plus z squared is plus 1 j, and 3y squared, well, we have 3 times minus 1 times 1 k. Okay, so that's 1 squared even, but it's 1. So what do we have here? We have I minus 4 plus 1, that's minus 3. So we have minus 3j. And we have minus 3k. So that is the gradient of f evaluated at point 2, 1, and 1. Now, let's look at the direction that we're asked. What we're going to do here is, that's the direction of the vector. Let's get the unit vector of that. So just the absolute value first off is square root of 1 squared plus 2 squared plus 2 squared, and that is equal to square root of 9, that's 3. So the unit vector there is equal to 1/3 I plus 2/3 j plus 2/3 k. That's the unit vector. Now, the directional derivative is the product of that and the evaluated gradient there. Okay, no, not that one. That one. Okay, so let's just write that out again. I minus 3j minus 3k and 1/3 I plus 2/3 j plus 2/3 k. And what have we got? Essentially just multiply out the pairwise components. So minus 1 and 1/3. 1/3 plus minus 3 times 2/3. That is minus 2. And finally, minus 3 times 2/3. That's also minus 2. So the answer we get is minus 3 and 2/3. Okay, so that is the directional derivative at that of the function there at that point in that direction. Okay, that ends this presentation. That's a directional derivative.